So now the question is whether the lone pair on oxygen will be donated toward metal center or lone pair which is situated on carbon will be donated toward the metal center. So this conceptually we have to explain purely on the basis of molecular orbital diagram. So for to make things easy, I have placed again the molecular orbital diagram in front of you. In this molecular orbital diagram, we already have discussed, and I am sure you are familiar with the orbital that what the figure that what in the figure are. Now, as you remember that the orbitals which are filled, they are called occupied orbitals, and orbitals which are empty, they are called unoccupied. So unoccupied molecular orbitals have been categorized on the basis of energy, and molecular orbital diagrams have been categorized on the basis of energy. So the orbital which is highest and is occupied, this is called HOMO. HOMO, designated as HOMO. HOMO means highest occupied molecular orbitals and highest in terms of energy. And among LOMO, among unoccupied molecular orbital, we have to designate them. And the one which is of our interest, that orbital which has lowest energy among them. So that orbital is designated as LOMO or LUMO, LOMO. So lowest unoccupied molecular orbitals. We have to explain chemical reactivity of a species on the basis of HOMO and LOMO. So the HOMO orbital is that one which is readily available for bonding. So this pair of orbital is preferably available for bonding, while the pair of electrons which are under this pair or underneath, they are now not available for bonding. So first of all, this pair will participate in bonding if this molecule is capable to donate further electron. Then these electron will become exposed to reactivity, which normally does not occur. But conceptually we have to make our concept clear that these orbital will be available for bonding after this has been engaged in such type of bonding. Now, if the ligand is capable to accept electrons from metal center or from any other appropriate species, so the orbital which is available for occupancy of those electrons is the one which is called as LOMO or lowest unoccupied molecular orbital. So the pair which has highest energy is now sensitive toward reactivity. This pair will get involved in bonding, and the orbital which is lowest available for electrons to be occupied if electrons are available. So this orbital is called LOMO, and these two orbitals are now of our interest, which will participate in bonding between metal and carbon monoxide. Now, another concept is that where this pair of electron is located, or from where this pair of electron will be donated toward metal center, and if metal is capable to donate electron back to the ligand, then where that pair will be accepted, and through which atom or which site will be offered by carbon monoxide for such type of bonding. So this also we have to explain on the basis of this diagram, as we have explained that the electronegativity between these two bonded atoms, carbon and oxygen, is different, and therefore we have constructed this molecular orbital diagram on the basis of their electronegativity. The one which has highest electronegativity is stable than the other one, and accordingly the lone pair of the bond pair of electron which has been accommodated here, it belongs to oxygen because it is more closer to oxygen, and on the basis of this closeness we call that this orbital possesses more characteristic of this orbital, atomic orbital. So this orbital belongs to oxygen, and this pair of electron which we have called as HOMO or highest occupied molecular orbital. So this highest occupied molecular orbital is now more closer to carbon. It means if this pair of electron is involved in bonding, so this pair belongs to carbon, not to oxygen. Therefore, through carbon bond will form. Now this situation further extends and if the pair of electron which is available with metal center on the other hand, that is now what we can say that is donatable, and carbon monoxide molecule is capable to accept that pair of electron. Now the orbital which is available for acceptance of that pair of electron for back bonding, this orbital is now located also at carbon, not at oxygen, because this is a lowest unoccupied molecular orbital or anti-bonding molecular orbital, and anti-bonding molecular orbitals are more closer to carbon, not to oxygen. So therefore, the bond from where electron pair is donated is located on oxygen is polarized. Is polarized on carbon, and the orbital which is capable to accept a pair back from the metal center is also polarized on carbon. Therefore, carbon monoxide will offer carbon as the getting center, not oxygen. And this is the absolute situation in carbon monoxide or carbonyl. And since carbon monoxide is attached to metal center through carbon, therefore the compounds being afforded by carbon monoxide are called organometallic compound, not coordination compound, because as per definition we have already defined the organometallic compounds, that those compounds which have at least one metal carbon bond, so they would be called as organometallic compound. And here in this case, since the bond between metal occurs through carbon with carbon monoxide, therefore the compounds formed with carbon monoxide are organometallic, not coordination compounds, because oxygen is not involved in initial bonding with metal center. Now, the with metal center, we have to extend our discussion further, and I hope this concept is now clear, that carbon monoxide will get attached to metal center through carbon, not through oxygen. If double bond is formed with metal center or back bonding occurs, so in back bonding again the pair will be accepted by carbon, not by oxygen, and such type of ligands where donor site and acceptor sites they are same, they are identical atoms, so such type of ligands are very feasible, are the compounds formed by metal, and such type of ligand they are more stable as compared to the one where the bonding sites are at different atoms. So this is the plus point or positive point of carbon monoxide, that both centers are situated on carbon, donating site and accepting site, both they are located on carbon, not on oxygen, and the resultant compound which are formed with carbon monoxide, they are organometallics, not coordination compounds. Thank you. From previous discussion, it is clear that the ligand HOMO, highest occupied molecular orbital, this was polarized on carbon, not on oxygen. So the bond pair which has been donated to metal center, which will be donated to metal center, will be that one which is located on carbon, not on oxygen. And oxygen is more electronegative and lower in energy. In addition to this, by star, LOMO is also polarized toward carbon, which we discuss or explain on the basis of molecular orbital diagram. So both LOMO and HOMO, they are situated or polarized on carbon, not on oxygen. Therefore, carbon is the feasible center which is available for attachment with the metal center. Metal carbonyl bonds are metal carbon monoxide pi overlap. This will be optimized at carbon, not at oxygen, to make a pi bond. So sigma bond or sigma electron pair, sigma bond is optimized at carbon center, pi bond is also optimized at carbon center. Therefore, carbon monoxide as a ligand, yeah, carbonyl as a ligand is more stable, the is more soft, and the resultant compound will be more stable if the metal is soft metal or electron donor. Now carbon becomes more positive upon bonding on coordination with the metal center, and as a result of this more positive charge on carbon, oxygen becomes more electronegative. So it explains the carbon monoxide polarization on binding with metal ion, and this type of polarization is called metal induced polarization. So this we have to explain further, that how this polarization is caused because carbon monoxide in neutral state, it is nonpolar and seems to be unreactive, but the reactivity is based on the extraordinary behavior, extraordinary good behavior or attractive behavior of carbon net of oxygen, where a pair of electron is available which can be donated and it accepts big electrons from metal center. So the net resultant charge on carbon become zero because a pair has been donated and another pair has been accepted. So net charge or electronic charge on carbon becomes zero, or what we can say that is negligible. But whenever this carbon monoxide reacts with metal center, so it becomes polarizable, or polarization is induced, and such type of polarization is called induced polarization. And this induced polarization drag the carbon monoxide toward reactivity, and further reactions can be explained or can be carried out with carbon monoxide in a different way. So that can be explained on the basis of further concepts, inshallah, in coming lectures. Now, this polarity, it activates carbon monoxide or the carbon more towards nucleophilic attack and oxygen toward electrophilic attack, because the comparative electron density we have to take on board or we have to account. So comparative electronegativity, sorry, electron density on carbon, it becomes less on carbon, or it becomes partial positively charged. So this partial positive and partial negative charge, so this is the carbon is now exposed to nucleophilic attack and oxygen is exposed to electrophilic attack. Electrophilic means this becomes positively charged, and the atom, the species which is electron loving, that will electrophile or electron loving, that will be directed toward oxygen, and the one which is positively charged loving, that will be directed toward carbon, in case of carbon monoxide or carbonyl complexes. So this polarization is now affected by other ligands which are also attached to metal center and net charge on the metal complex. So if the net charge on the metal complex is negative, so we will observe one type of polarization. If net charge on the metal complex is positive, so we will observe another type of polarization or reactivity in case of species. Similarly, if this ligand is electron donating, then the electron density on metal center will increase, and that electron density will be shifted toward carbon. So positive characters on carbon will decrease. And if the ligand is electron acceptor, so electron density from metal will be shifted toward this ligand, which has been generally represented as Ln, and as a result of this shifting of electron density, positive charge on carbon will further enhance, and the carbon center toward nucleophilic center will further be exposed with extra activity or with extra charge, and reactivity will become, our rate of reaction will become more, our reactivity will increase in case of that fragment where the ligand is electron withdrawing. So we have to take on board again the Ln ligand, or generally this ligand is electron withdrawing group or electron donating group. So in case of electron withdrawing and electron donating group, the reactivity of carbon monoxide, as we discussed here, will also change in the opposite direction. Thank you.